Hi there. In our last video, we had a look at using the chain rule to differentiate. In this lesson, we're going to have a look at the product rule and how we can use that to differentiate when we have one function multiplied by another function. Okay. Now, in your textbook, it expresses the product rule in two different ways. I like to express it a different way, which I'm going to show you now, and that is that dy dx, or before we look at dy dx, if y equals u, which is a function, times v, which is another function, then dy dx is equal to u times v dash plus v times u dash. Okay, so let's have a look at how we can apply that to an example. All right, so we're having a look here at worked example 4, where we've got g of x is equal to x cubed times sine 3x, and we need to find the derivative of g of x. Okay, so with g of x, we have u and we have v. Okay, u is equal to x cubed. V is equal to sine 3x. Not sure why I'm still writing in red, so I'm just going to flick over to my black pen now, and I'm going to work out what u dash is. Okay, so the derivative of u is 3x squared, and v dash is equal to, sorry, I accidentally missed the 3 there. So v dash is equal to 3 cos 3x. Okay, so now we know from what I wrote up here that dy dx is equal to u times v dash plus v times u dash. Okay, it doesn't matter which way we do that. Now we know all of those things. We've got u is here, u dash is here, v is here, v dash is here. So they're all the things that we need to substitute into the formula. So therefore, we've got u times v dash, which is x cubed, times v dash, which is 3 cos 3x, plus v times u dash, so that's sine 3x, times u dash, which is 3x squared. Now it's just a matter of simplifying, so therefore I have 3x cubed cos 3x plus 3x squared sine 3x. Now if we wanted to, we could simplify further than that by taking out a common factor of 3x squared. Okay, in your textbook it does not do this, so it probably doesn't matter either way, but just to show you a different answer that you could get, which would also be correct, we would have 3x squared as a common factor out the front, and we would multiply that by x cos 3x plus sine 3x. So either of those would be an acceptable answer, either that or that. Okay, so now let's have a look at another example. Let's look at worked example 5. So again, we have a function, we have a function multiplied by another function. Okay, so essentially we have y equals u times v, u equals e to the power of 2x, v equals x plus 1 all squared. Okay, now let's read this question because we need to actually find more than just dy dx. We need to find the equation of the tangent at the point 0, 1. Okay, now to find the equation of the tangent, that's a straight line. Okay, so the straight line equation is y equals mx plus c. Okay, so what we need to do is we need to find the gradient, which is m, at that point. Okay, and then we can look at finding c a little bit later on. Okay, so the first thing we need to do is determine the gradient, and we can do that using the derivative. So we need to find the derivative first so that we can find the gradient of the tangent, and then we can go about finding c. Okay, so let's have a look back at the equation and using the product rule to differentiate. So u dash is the next thing we need. which is 2e to the power of 2x. V is a little bit tricky because we've got a function within a function, okay? So what I mean by that is we could also express V as, and I'm going to use the chain rule where we would normally use U, okay? I'm not going to use U just for obvious reasons because we've got U somewhere else. So I'm going to use A squared. So V equals A squared, where A equals x plus 1, okay? So we're going to use the chain rule to differentiate within the product rule. So V dash is equal to 2A, A dash is equal to 1, okay? Now, we know that when we're using the chain rule, we use, or we do this times this, and we're just going to substitute A back in, okay? So 2A times 1 is equal to 2A, okay? So V dash equals 2A, A is equal to x plus 1, so therefore that's my U dash value, okay? So now the things that I need to put back into to find the product rule, or to use the product rule to find the derivative, I need U, I need V, I need U dash, I need V dash, okay? Once I've got all those things, I know that the derivative is dy dx equals U times V dash plus V times U dash. It doesn't matter which way around we do that. If you did it V times U dash plus U times V dash, that's totally fine. It doesn't make any difference at all. Now, let's evaluate. So we've got dy dx is equal to U times V dash. So we've got e to the power of 2x times 2 times x plus 1 plus V times U dash, which is x plus 1 squared times 2e to the power of 2x. Okay, so now it's just a matter of further evaluating that. So we'll have, therefore, that equals 2e to the power of 2x times x plus 1 plus 2e to the power of 2x times x plus 1 squared. Okay, now if we look at this, we've got a common factor between both of those terms, okay? And that is 2e to x times x plus 1. That's a common factor with both of those terms. Now, to put in the other factor for each of those terms, the other factor or the paired factor with that first term is 1, okay? And the factor that goes with that for the second term would be x plus 1, okay? I'll put it in brackets initially, but we don't actually need the brackets there. So now I know that I'm just going to simplify that second bracket. So I know 2e to the power of 2x times x plus 1 times x plus 2, okay? And that is our correct derivative. But remember, we need to find more than that, okay? We don't just need to find the derivative. We need to do some other stuff. So we've done that, great, okay? Now we need to use that to find the equation of the tangent to the curve at that point, okay? So at the point 0, 1, that means that, what color am I going to use? Ooh. So that means at that point we've got x equals 0, y equals 1. Okay, so we need to find the derivative when x equals 0. Okay, so what I'm going to do is I'm going to let x equal 0 in that equation. So then we'll have 2e to the power of 0 times 0 plus 1 times 0 plus 2. Okay, 2e to the power of 0, anything to the power of 0 is 1. So I have got 2 times 1 times 2. 2 times 1 times 2 equals 4. So that means the gradient at that point is equal to 4. So therefore, now I know that the equation of my tangent is y equals 4x plus c, okay? So the next thing we need to do is we need to work out what this c value is. Now, when we're finding c with a linear equation, we need to know a point that exists on that line, okay? we know a point that exists on that line. It's 0, 1. Okay, so what I'm going to do is I'm going to use 0, 1 for x and y to find c. So therefore, I've got 0, 1. So 1 equals 4 times 0 plus c. Okay, so therefore, c equals 1. And the equation of my tangent, therefore, is y equals 4x plus 1. Okay, let's just quickly scroll up, see if we've answered everything that the question was asking of us. We found dy dx, excellent. And we've found the equation of the tangent at that point. Great, so we've done all of the things that the question asked of us. We know that this is correct. Well done to us. Cool. All right, that's everything that you need to know for the product rule. If you have any questions or get stuck on anything, please don't hesitate to contact me. My email address is on Compass, but just in case you can't be bothered going on to Compass, it's just jason.dafe@education.vic.gov.au. Cool. I'll see you for the next video where we'll look at the quotient rule.